guys, in this video I am talking about chapter number 14, Electromagnetism part 4. Motion of charged particles in an electric and magnetic field. When an electric charge Q is placed in an electric field, the experience of a force F parallel field, it is given by F equal to QE. If the charge is free to move, then it will be accelerated according to Newton's second law as A equal to F over m. If electric field is uniform, then acceleration is also uniform, and hence the position of the particles at any instant of time can be found by using equations of uniformly accelerated motion. When a charged particle Q is moving with a uniform velocity v in a region where there is an electric field E and magnetic field B, the total force F is a vector sum of the electric force QE and magnetic force QVB, that is F equal to FA plus FB. This force F is also known as the resultant force. The determination of E over m of an electron. Let a narrow beam of an electron moving with a constant speed v be projected at right angle to a known as uniform magnetic field directed into a plane of paper. We have seen that electrons will experience a force F equal to EV cross B. The direction of the force will be perpendicular to both V and B, as the electron is experiencing a force that acts as right angle to its velocity, so it will be changed the direction of the velocity. The magnitude of the velocity will remain unchanged. The magnitude of the force is EVB sin theta. As theta is 90 degrees, so F equal to EVB. As both V and B do not change, the magnitude of the F is constant. Thus, the electrons are subjected to a constant force EVB at the right angle to their direction of motion. Under the direction of this force, the electrons will be move along a circle as shown. The magnitude force F equal to BeV provides the necessary centripetal force to the electrons of mass m to move along the circular trajectory of radius. Thus, we have E over m equal to V over BR. If V and R are known over E over m of the electron is determined, the radius is measured by making the electronic trajectory the hydrogen at low pressure. This tube is placed in a region. Electrons are shot into this tube. They begin to move along a circle under the action of the magnetic force. As the electrons move, they collide with atoms of the gas. This excites the atoms due to which they emit the light, and their path becomes visible as a circular ring of light. The diameter of the ring can be easily measured. In order to measure the velocity of the electron, we should know the potential difference through which the electrons are accelerated before entering into a magnetic field. If V is potential differential, its energy is gained by electrons during their acceleration VE. This expression is the kinetic energy of electrons. Cathode ray oscilloscope. Cathode ray oscilloscope is a very versatile electric instrument which is in fact a high speed graph plotting device. It works by reflecting beam of electrons as they pass through a uniform electric field between the two steps of parallel plates. The diffracted beam then falls on a fluorescent screen where it makes a visible scope spot. It can be display graphs of a function which rapidly vary with time. It is called cathode ray oscilloscope because it traces the desired waveform with a beam of electrons, which are also called cathode rays. The beam of the electrons is provided by an electron gun, which consists of an interactively heated cathode grid and three anodes. The filament heat cathode C which emit electrons. The anode A1, A2, A3 which are at high positive potential with respect to cathode accelerate as well as focus the electronic beam to fixed spot on the screen. Control the number of electrons which are accelerated by anodes, and thus it controls the brightness of the spot formed on the screen. Now we would explain how the waveform of phase voltage is formed in GCRO. The two set of deflecting plates are usually referred as X and Y deflection plates because of voltage applied between the X plates deflect the beam horizontally on the screen parallel to X-axis. Voltage screen along the Y-axis, the voltage that is applied across the X plates are usually provided. The bias circuit is built into the CRO. Okay guys, thanks for watching this video. Bye guys, subscribe my channel.